last, it's kind of hodgepodge of things. It's a lot of things, but they're not very long. Outliers, influential points, R squared, and computer output. They're really short. So it seems like a lot of stuff, but really is not. First thing is outliers and influential. These are all visual. These are all visual. Visually, do you see? So outliers, I highlighted some things about outliers. The things about outliers when we're talking about scatter plots is that they, first of all, they lie outside the overall pattern. So there's an overall pattern going on. Something that doesn't fit, not doesn't fit, doesn't lie with that pattern, does opposite of what we should do, is considered an outlier. Points that have large residuals. What's a residual? What's a residual? Or how does something have a large residual? Yeah, just exactly. Far away from that red line there. So if the farther away those blue dots are from that red line, they have a big residual, right? Above the line means a positive residual. Below the line means a negative residual. Okay. So if it's influential, it has a large, or sorry, if it's an outlier, it has a large residual, and therefore it lies outside the pattern in the y values. So it's too high or too low, right? The y, its main discrepancy is the y. Okay, that's outlier. Influential could be a little different. Influential is an observation is influential if it's an outlier in the x side to side. Okay, removing an influential point would markedly change the result of correlation and the regression line. So if I were to take away a point, so like let's go back here. If I were to take away one of these blue dots, the red line would change slope or change y-intercept. That means it's influential. Okay. If I were to take away one and it wouldn't really do anything to the red line, it's not influential. Okay. So let's look at these two. So first graph, the one on the left. Question is it an outlier? Are there any outliers? Are there any influential points? Are there any both or neither? So outliers, let's look at outliers one more time. Outliers means outside the general pattern. So there are any dots that lie outside the general pattern. There's one, right? Bottom right corner. That guy right there, right? These are trending to go up, right? That one is not. It should be up here, right? See that difference in y? That makes it an outlier because there's a difference in y. Okay? My question is it also influential? So if it was there, so if it was not there, let's say it's not there. Let's say it's not there. The regression equation would probably look something like, or the line would probably look something like that, right? Now, if I were to add that point in there, what would happen to that blue line? The slope would change, right? Oops, no. It might do something like that, right? Because it has to account for all of the dots. So if it has a dot down there, it's going to have to change the slope a little bit. Whereas if it wasn't there, that would be the line right there, pretty solid line right there. But because of that blue line, it kind of has to change a little bit, right? So I would say that this guy right here is an outlier and it's influential. It's both. Okay. Because of those facts, because of those two things. Okay. Now look at the second one. Obviously, yep. Well, obviously the guy that stands out is this guy over here, right? That guy that stands over there. Would that be an outlier? Would that be an influential? Or would that be neither? That's my question. So to be an outlier, it would have to have a large residual, and it would have to fall outside the line, outside the pattern and the y values. Okay, so without it, let's say, or let's say with it, the regression equation would probably look like this, right? Something like that. What if I take it away? Will it change? Very little, right? Because it's already going in that direction, right? It's already going in that direction. Now, is it going to have a residual? It'll probably have the largest residual out of all of them because these are all pretty close to the line. These errors aren't that bad. The residuals aren't that bad. This guy would probably have a larger residual. So for that reason, it could be an outlier. I would consider it an outlier. Is it influential though? Is it influential to the blue line? If I take it away, would that blue line change at all? Not really. It fits where it's kind of going, right? It sticks out because it's way out there, but it's not really influential. Okay, it's not really influential. Okay, now let's look at a couple down here. Let's look at 4 of them down here. Let me label these so I can A, B, C, D. Does A have any dots that are influential or outliers? No. If I took away any of these dots, the blue line would, my blue line, purple line wouldn't change. It's not purple on your paper, I know, but for A, it wouldn't change at all if I took away any of those dots. What about B?
No outliers.
If I took away just one dot, would that change anything? Not really, right? It's more of a pattern going on there, right? So yeah, this would, I wouldn't see, I don't see any outliers or influential there. So here, none. Here, none. How about C? That dot right there. Is that influential? Is it an outlier or is it both? Because why is it an outlier? Because it's got a large residual compared to the rest, right? And if I were to take it away, it would be perfect. R would be +1 because they make a straight line. Mhm. Exactly. Influential or outlier and influential. That guy right there. Okay. D, this guy out here. It's definitely influential, right? If I take that guy away, now my line's going like that. It's going exactly like that, right? R is 1. So definitely influential. Is it an outlier? Doesn't have a large residual, right? Doesn't have a large residual. It could be an outlier because there's a distance here. There's a gap there. So it could be considered an outlier that reason. Okay, but it's not an outlier because it's got a large residual. It has actually one of the smallest residuals because it's right on the line. Okay, so you just got to be careful. You got to know the difference between what's influential, what's an outlier, what's both, what's neither. Okay, so it again, that's just, it's more of an eye test. It's more of an eye test than anything. Okay, an outlier is let's see, an outlier is influential. So anytime it's an outlier, it's also going to be influential. But the opposite is not always true. An influential point is not necessarily an outlier. This guy right here, case in point, right? So if it's an outlier, definitely influential. If it's not, if it's just influential, it might not be an outlier. Okay, so you just got to check those. All right, that's one of them. The next one, R squared is probably one of the most interesting statistics we talk about all year. I like it a lot. We don't use it a lot, but it's very interesting. R squared. So its name, it's called R squared because is it literally R squared? You take R and you square it. That's R squared. Okay. It's called the coefficient of determination. A lot of people on tests, they get R and R squared confused. R, remember, is correlation coefficient. R squared is what we call coefficient of determination. So they're different. They're related because if I have R, I can just square it and get R squared. If I have R squared, take the square root and you get R. Okay, so they're related like that mathematically, but they're different things. Okay, so what is R squared? So the square of the correlation coefficient, or R squared, represents the percentage of change in the Y variable that is attributed to the relationship with the X variable. That sounds very confusing. This is what it is. It explains it explains why two things are correlated. Okay, so for example, let's do a problem. Let's look at one that we've looked at before. You don't have to dig it out. I'll find it. I'll find one that we've done before. This guy here. We did a couple days ago, right? Shoe size from class, one of my past class, shoe size versus height, right? You guys actually found R, right? You guys found R for this guy was 0.777, and you guys said there is a positive, moderate to linear association, right? We did that one. Well, if I have R, how do I find R squared? Just square it. So R squared for this guy. Say it again. Do it again. Squared. It's actually going to get smaller. Yeah, it'll get smaller. 0.60. 0. So 0.60, like that. Okay, which is about 60%. So okay, so what R squared is, it's an effect size. How much of an effect is one having on the other? So we would say the reason why the response is happening, response is heights. The reason why people are getting taller is because their feet are getting taller. So it's an effect. It's explaining why the Y is happening. And it's saying 60% of the reason why people heights are what they are is because of their shoe size. That's what it explains. It says it relates the X back to the Y. Why is this happening? Because of X. 60% of the reason why is because of your foot size. Okay, that one's kind of a little confusing. Let me get another one. We did R. Did we do R for this guy? I don't think we did. Where's R? Let's see if we can get another R here. Let's see. There we go. Let's do the one we just talked about. A lot of you got this one. The one we did yesterday. We talked about head size and GPA. We found that it's kind of all over the place, right? It's kind of all over the place. The dots were all over the place. There was barely any kind of correlation. That's barely anything, right? It's close to zero. But we said there's barely a negative weak linear association. Okay. So if I were to find R squared here, let's see what I would get. 0.0026. That's not even 1%. That's like less than 1%. So what our findings would show is the reason your GPA is what it is. There's less than a 1%. So the reason, how do I say this correctly? The reason your GPA is what it is, 1% of that has to do with your head size. The other 99% plus has to do with other things. Because there's a very low correlation. There's a very low correlation between your head size and your GPA, right? So what R squared is saying is it's explaining why your GPA is what it is. Why is your GPA is what it is? Well, when I compare it to head size, it's about a 1%, less than 1%. So about 1% of the reason why your GPA is what it is because of your head size. Does that make sense? Very low, right? 1% is very low. 1% of the reason why your head size, your GPA is what it is because of your head size. So do those two things have anything to do with each other? Not really. 1% of the reason, right? 1%. 1% of the reason why your GPA is what it is because of your head size. It's explaining why, it's explaining the response. Okay? Let's take a look at another one. Let's take a look at another one. Nope, that's today. The first one we did. Body weight and backpack weight. So let's see, 0.095. So R squared would be 63.2, which is about 63%. Okay, so what this R squared is saying is about 63% of the reason why these people can lift their backpacks is because of their body weight. So any change in backpack weight, 63% of the reason why that's happening is because of their body weight. More than half of that reason, right? That makes sense because if someone's heavier, they can support more weight, right? Not everybody, right? There were a couple people. There was one person out here who was on the heavier side of the list, and their backpack didn't weigh as much, right? So that's what R squared says. R squared explains things. Why is this happening? Well, 63% of the reason why your backpack weighs what it is because of your weight. Okay? That's what it is. Okay? That's what R squared says. So, in other words, it's accounting for the variation. So one is accounting for the variation of the other. Okay? Why is the response the way it is? Because of it'll tell you what percent of the response is what it is based on the explanatory. Okay? So if I had a 1, let's say I had an R squared of 1, or R of 1. Let's say I had an R of 1. What would that R squared be? Here. I don't think you need your calculator for that one. That's 100%, right? A 1 would look like this. Right? Everything lines up perfectly. So I would say 100% of the reason why the response is happening is because of the explanatory. There's no other reason why it's happening. This is happening because of this. They're directly tied. Okay? That's what would happen there. No reason why we would even question that. Or the opposite. If I had one like this, that's a negative 1, right? It would still be 100% because negative 1 squared is 1. So it would be, you would say that 100% of the reason why Y is happening is because of X. It's an effect size. It explains. It explains in the variation, okay? Because there are variations. There's always variation, right? Not everything is on this line. There's always variation. There's always going to be variation. And that's what R squared explains. Why aren't all of these dots on this blue line? Why aren't all of these dots on this blue line? Because of the variation, okay? So there was a famous one. I always tell this every year because it's interesting. The most famous R squared thing I can ever, one of my professors told me this in college. So they did a survey. They did a study where they said the question was, does the school that high school students attend affect their success, their GPA, what college they go to, all of that good stuff, right? So they did a bunch of survey. They did a bunch of stuff like this. They got a bunch of data like we did, and they compared. X was the school you're at. Somehow they were able to quantify that, and then they compared it to how success you had, college, career, all that stuff, right? GPA, stuff like that. What percent do you think? What was the R squared? What do you think was, so you guys, 10 Central. What percent do you think is Central responsible for? 100% would be, it's all Central, nothing else. Nothing else, it's all Central. 0% would be, has nothing to do with Central. It's all me, it's all outside things, right? Where would you say R squared is for that? Where would you say R squared? Above 50, below 50, closer to 100, closer to 0? 70%. So 70% of the reason why you're doing well is because of the school. That's what you're saying?
Yes.
Okay. Anybody go higher, go lower? 80, higher? 60? You know what it was? Lower? 10? What they found was, and this is not Central, this is every school. They did it nationwide. 7%. 7% of the reason why you guys do what you guys do, how well you guys are doing, is based on the school. That means 93% of it has to do with other things. 93% of it has to do with how hard you work, home life, um, motivation, things like that. All of those things, right? Those are the things, right? Everyone says school, school, school. I go to that school, I'm going to do well, right? That's not necessarily the case. It's everything else. It's everything else that has to do with that. As much as I would like to think our school positively infects you, it does, but it's not as big as you guys think. It really is kind of minimal. In other words, you guys could be at any school anywhere, and you guys probably would still be in the same position you are right now. Because it's not necessarily where you're at, it's who you are, right? There's a big, politically, there's one of the big things is school choice. School choice. So what this means is, so um, the school, public schools get money. They get money based on, for every student. For every student, they get money for the year. It's somewhere between 10,000 and 15,000 for every student. So for every student they get about 10 or 15,000 for a year for that student. To do everything the school pays for, that's where the money comes from. It comes from taxpayers. So there's a big topic politically that says, parents say, you know what, just because I live in this area, I don't want to send my kid to that school. Why don't you give me the taxpayer money, that 10,000 to 15,000, and I'll send them to another school, a private school maybe. It's called school choice. It's called school vouchers, right? Because what they're saying is where school you're at has a big say in how you're going to do in school. Whereas statistics don't say that. Statistics say if you're a good kid and you work hard, you're going to do well no matter what school you go to. You can pick any school in Fresno, any school in Central, any school in Clovis. There's kids that go to UC Berkeley, Ivy League schools, Stanford, USC, whatever schools, the big schools, right? Everywhere, right? There doesn't really matter the school you're at. It matters everything else, right? Your home life, how hard you work, how motivated you are. All of that stuff is what moves the needle for success, right? That's what moves the needle for success. You know, the school you're at does have something to do with it, but it's only 7%. 7% is not much, right? That's what it showed. Okay, that's what it showed. That's what R squared is. It explains why are you guys doing well? Well, 7% of it has to do with Central. It's not a lot. It's not a lot. And that's not just Central. If you were at Clovis High, Fresno High, Sunnyside High, any of those schools, it would still be 7%. Okay? Because the reason you guys are doing well is because you put the effort in, right? You guys are responsible for that. Okay? That's what this is. So the key word here, because most likely this is going to be a multiple choice question. I'll tell you how to solve these. If it talks about R squared or coefficient of determination, look for the one that says that guy right there. Accounts for variation. Accounts for the variation. That means R squared. Anything that accounts for the variation means R squared. So there'll always be one out of the 5 that says something about blah, blah, blah percent accounts for the variation in this or that. That's what it is. Look for that. Okay? It's a super interesting concept, but we don't cover it that much in this class, unfortunately. Okay? Standard deviation. Okay, we talked about standard deviation. So pretty much what this is the standard deviation of the residuals. So standard deviation of the residuals. It talks about, on average, how far are each of the points away from the regression line. So if I was to add up all of the distances, where's my, there we go. All of the distances. If I was to add up all of the distances from the blue, how far the blue from the red, if I was to add them all up and divide by however many dots there are, that's the standard deviation. The average distance away from the regression line. So on average, each of those blue dots is blank away from the regression line. If it's positive, that means they're on the positive side. If it's negative, that means they're on the negative side. Right? Okay. Actually, no, scratch that. They'll always be positive. They'll always be positive. The distances, what they do is they find the distance and take the absolute value. So if it's a positive, they keep it positive. But if it's a negative distance, they just make it positive. Okay, so that's what that is. Okay. Oops, wrong one. Okay, so here we go. Let's try this one. What I want you to do now is I want you to do the next example. Do A, B, C, and D. A, B, C, and D. Okay? Temperature and ice cream. Temperature and ice cream. So when you do that one more time, I'll do it one more time. So stat, edit. I want to do a third list. So I go here, go up, highlight that, hit enter once. Because if you hit enter more than once, the highlight up here where L3 is goes down, and then that's not what we want. Okay, we want it to stay there. We want a blinker on the bottom, and we want L3 to be highlighted. Okay. All right. So now to create the residuals. Remember, residuals is observed y minus predicted y. Observed y's are in L2. Minus parentheses Okay. Observed or predicted wise, I need to calculate. I don't have those. I need to calculate them. Well, we calculate them just like you did in part A. Part A, you calculated it by plugging it into, you plug in the number. In this case, the number for part A was 83. You plugged in 83 into your equation and you got a number, right? Well, we're going to do that, but we're going to do it for the entire list. So I need my equation first. So my equation is in vars. So vars right next to clear. You're going to go down to statistics, enter, go over 2 tabs to EQ, enter. There's the equation. If your equation, sometimes when you do that, it's just blank, a blank at the bottom. Nothing happened. That means your calculator forgot the equation. So you have to redo the equation. Find A and B and R squared all over again. Okay? Yeah. I'll come back. Yeah. Okay. So I don't want X. Some of you guys were leaving X there. I don't need the explanatory. I don't need X anymore. I want to plug in numbers for X. I want to plug in the X for X. So I'm going to plug in. So instead of X, I'm going to say parentheses. I want L1. Close parentheses, and then I got to close parentheses again because I opened one up earlier. And then you're going to hit enter. There are the residuals. Okay. We haven't talked about this. One thing. If I were to add up all of the numbers in L3, add them all up, what do you think I'd get? You get 0. Yeah. If you were to add up all the numbers in L3, negative 18.2, 4.2269, 10.198, all the way down. If you were to add them all up, you would get 0. Because all of that's why, because this is how far each of them are, this is how far each are from the predicted line. Well, to be the predicted line, it has to be, I don't want to say equally distanced because it's not equal distance. None of these are the same, but it has to be centrally located so that all of them balance out. So if you were to add up all the residuals, you would always get 0 or something really, 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 really close to 0. Okay. So they're the residuals. So now I want to plot. So I go to stat plot, make sure it's on, and make sure it's on scatter plot. Make sure it's on L1 and L3 for me. If you're not in L1 and L3, make sure you change it to wherever you're at. Okay, make sure it's blinking on. Okay, zoom, and then zoom stat. And there's your graph right there. That's the graph you're doing. The X is temperature, the Y is residuals. Okay, the Y is residuals. How do I do letter C? Yep. I could use the calculator, that one, but how would I use it? That's my question. Yeah, you could do it that way. You could use the calculator to do it. So what is this question? What's difference? Why? How is this question different than the one they've been asking? You guys have seen earlier. The what? That, yeah, they're changing it up. They used to say find the residual for this value. Now they're saying here's the answer. Give me the part that's missing. Right? They're saying on a 95-degree hot day, that's X. The residual was 6.214. How many pounds of ice cream were sold? Well, pounds of ice cream is y. So that's what they're missing. They're missing the y. They're asking for y. My question is, how do I find y hat? How do I find y hat? Plug 95 into your equation. You got it. Plug 95 into your equation from part A. You have it. So let's see. Negative, let's see, 5.774 times 95 plus a negative 331.839. And I get 216.691. That's how many I would expect to sell. On a 95-degree day, I would expect to sell, or I would expect them to sell around 216, 217 pounds of ice cream. How did I get what? I plugged it into the equation here. The equation that I got for A. Solve for Y. Add 216.691 plus 216.691. And you got your answer. $222.905. For the residual to be 6.214, the observed would have to be a little bit more than the predicted, 222.905 pounds. Again, sometimes they'll change it. Just like last chapter, sometimes they changed it. Sometimes they gave you the z-score and the percent, and then you had to go back and find x or find the mean or find the standard deviation. It's the same thing. They've given you different pieces, and you just have to find what's missing. Okay. Okay, r squared. R is 0.972. R squared is 0.945. So if that was a percent, it'd be 94.5, around 94.5%. It's pretty high. So I would say 94.5% of the reason why they're selling so much Y is because of X. 94.5% of the reason why Y is happening has directly to do with X. So instead of saying Y and X, say temperature and ice cream sold. So 94.5% of the reason why ice cream is being sold the way it is due to the temperature. That's almost 100% of the reason. That's pretty much the reason why. Makes sense, right? Makes sense. If temperature is high, more ice cream is going to be sold. If temperature is low, less ice cream is going to be sold. Makes sense. That's what it's saying. It's explaining. It's an effect size. What is the effect that temperature is having on ice cream sales? Okay. What is the effect? E with an E, not an A. Effect. What is the effect that temperature is having to do on ice cream sales? Almost 95% of the reason why ice cream sales are what they are is because of temperature. That's pretty high. Can't go above 100%. Okay. All right. Okay, we got one more thing to talk about. It doesn't take very long. Tomorrow, what we're going to do is we're going to go over computer output. And then the rest of the time, I'm going to give you on your assignment. I'm not going to assign you anything yet because I want to give you some class time to start it. Okay? So no new assignment. It'll come tomorrow. Okay? All right. And then, yep, that's the last part of the chapter.